Hi, welcome back. First of all, I want to thank you all for 50 subscribers. We broke this milestone a couple of days ago, and I don't know, I never got a chance to properly thank you for this. So thank you a lot. Uh, in the end, this channel is not about me trying to tell you something or like a course or something. It's me learning, and if you like it, maybe you can learn together with me. I'm not very smart, so I I understand things pretty slowly. Uh, maybe you do this a lot better and faster than I do. So usually, how my episodes worked is that I start coding, and then after coding, if I have the time and energy, I do some articles reading. In today's one, in today's live, I think we're gonna do the complete inverse of that. First, we're gonna go through some articles that I found here from the last time, and then, if I have time, I'll also code a little bit. So, I wanted to start with this one. It's called C++ coroutines without heap allocation. Nothing of this, for me at least, makes any sense. So let me open the article. So it's an engineering blog on pigweed.dev. C++. C++ 20 coroutines without heap allocation. Okay, I need to ask the obvious question. What is the heap allocation in C++? Heap allocation in C++. Just a second. Oops. Oh yeah. So what's heap allocation in C++? Heap allocation in C++ refers to the dynamic allocation of memory during the runtime of a program, as opposed to compile time or static allocation. Memory allocated on the heap is managed manually by the programmer and can be allocated or deallocated at any point during the execution of the program. This is especially useful when the size or lifespan of an object is not known at a compile time. So compared to C, a programming language that I'm working, doesn't seem like a lot has changed, at least in the definition of the heap. But most probably the real meat of the heap allocation is the allocation of the heap. So let's read through it. Let's see what are some key points about heap allocation. So it's dynamic. Heap memory is allocated dynamically using the new operator in C++. This memory remains allocated until it is explicitly deallocated by the programmer using the delete operator. This is how we allocate. So first of all, what are the differences? What are the most important differences between C and C++? Let me just go back here. So this is how we allocate memory with the new keyword. And we can also manually deallocate. The memory allocated on the heap needs to be manually freed using the delete or delete operator, depending on whether it is a single object or an array. Failing to deallocate heap memory leads to memory leaks, which can exhaust the available memory over time. Let me just hide the bookmarks bar so I have more space here. Yeah. I understand this. And I have another question for... He's still writing. Wow. Okay, a lot of changes. Okay, enough. Stop. Please stop. Okay, it's stop. So these are the examples of heap allocation. In the above example, we have this. We have this. We need to manually deallocate. Now the differences between the heap and the stack. Stack memory in the stack is automatically managed, allocated, and deallocated as functions are called and returned. And heap memory on the heap is managed manually has a larger size limit and is more flexible for dynamic memory management. I already know this. So what are the advantages of heap allocation? Allows allocation of memory at runtime when the size and duration of data are unknown at compile time. Disadvantages, and here's an example. So what are the most important differences between C and C++? They are both powerful general-purpose programming languages, but they have key differences in terms of features, paradigms, and usage. So what's this? This is procedurally. C is a procedural programming language. C++ is a multi-paradigm language. Based on OOP, C has no support for it. C++ has full support for OOP. What else do we have? Let me just check this quickly. Some libraries, some memory management data. C, manual memory management using mallocate and free. In C, you allocate and free memory manually using functions like memory allocate, but C allocate, C allocate and free. On the other hand, C++ has manual and automatic memory management using new and delete with support for, oh man, what's this? C++ allows dynamic memory allocation with new and delete operators, which are easier, more flexible data abstractions. Okay, a lot of changes. So C has no namespace. C++ supports namespace. Input output. Okay. So what I wanted, what are the biggest differences when it comes to heap allocation? Like, ChatGPT is so helpful. Things that I would need hours of googling, I can just find answers here. Of course, I'm not gonna ask for medical help or something that's serious, but the most basic definitions are always in like 99% of the cases correct, and they are curated, and they give you the, depending on the way you construct the prompt, they give you the best information available. So I'm actually quite happy with using ChatGPT, at least for the most basic things. For the other ones, yeah, there's definitely some fact checking that needs to be involved. What are the biggest differences when it comes to heap allocation? Okay, when comparing heap allocation between C and C++, the key differences revolve around how memory is allocated, managed, and deallocated, as well as the syntax used for these operations. Let's break down the biggest differences. So this is the syntax for heap allocation in C. All of these different methods. I forgot the little intricacies and differences between those, but doesn't matter. Now C++ uses new and delete, which are more convenient and type safe. In C, okay, so let's see if I understood what happened. Let's allocate. How much? The size of int, and int is 8. How big is int? How big is int in C? It's like 4 bytes. I want to say 8 bytes. Int 2 or 4 bytes. Okay, it's 4 bytes. So this was in 2012. How big is int? How what is the size of int on most modern computers? 4 bytes, 32 bits. Okay. Why did I thought that it's 8 bytes? And car is car 8 bytes. What is this? It's car 8 bytes. Man, he's still writing. 1 byte. Ah, yeah, it's 1 byte. It's at 8 bits. Maybe, yeah, I made a little switcheroo in my mind here. So let's just switch all the way back. So this is an example in C using malloc and free. We are allocating the size of int. I think this is just casting, right? I'm casting it to an integer pointer. If the pointer is null, something happens, and then we deallocate memory. And how it's done in C++, we are just using the new keyword, and then we deleted the pointer. You must cast the result of malloc to the correct type and check for null. In C++, new automatically returns a pointer of the correct type, and if allocation fails, it throws a bad allocation exception. Okay. Now another point is the way objects are constructed in and destructed. Okay, so C is bare bones. There's no object-oriented programming. Heap allocation uses malloc or calloc. We don't have any constructors. Manual insert. Okay. C++, when you allocate memory using new, the constructor of the object is called automatically. Likewise, when you use delete, the destructor is called automatically before the memory is deallocated. So this is a structure. This is C. It's not C++, so it's a structure. We allocate the size of the struct point. You could alias this. Then we set this pointer attribute, set this one as well. Okay. Now C++ is using constructors. We have a class, we have some public properties, we create the new instance like this, and we just delete it. How are arrays done? Okay, I'm gonna skip. Reallocation of memory is done. How? Reallocate. Okay. So I have enough prerequisite knowledge for this article now. Pigweed.dev. Pigweed now provides support for coroutines on embedded targets. So what's this? Again, I haven't worked in I don't think I've ever worked in C++. I mostly worked in C. So all of this for me is like Greek. But I want to understand that. I want to... I don't know. I want to be able, at least be able to read code. Like the Latin languages, they are somewhat mutually interchangeable. And people at least, or the Slavic languages, people at least know the basics, or they could read a couple of letters, a couple of numbers, or stuff like that. So I want at least to be able to be proficient in reading it. So what's this? It's an object. It's an object that takes a pointer of a context, takes a time, takes what I'm assuming is LAD, takes the times, then it iterates through the times, it turns on the LED, waits for some time, turns off, and returns OK status. So it seems as if this Coro class API is something built in Pigweed's codebase. This post details how we accomplish this, what challenges we encounter, and how you can get started using coroutines on embedded. If you are a C++ embedded developer looking for an ergonomic way to write async code, a Rust user curious about C++, a C++ community member who wants to make embedded developers happy. Okay, why use coroutine? I don't know how to produce it properly. Coroutines for embedded. Now, the agile question: what is a coroutine C++? Help me, my dear friend. So yeah, coroutines are a form of functions. They can be suspended and resumed, allowing for more flexible control flow. So coroutines can stop the execution. They can be resumed later. Interesting. Really interesting. Key characteristics of coroutines: they can suspend and resume, they can lazy execute. So they have a specific syntax. So yield is also a keyword in JavaScript and TypeScript. It's because these types of methods also exist in JavaScript as well. So what's happening here? We have a structure called generator. We have a structure called promise type. It takes the current value. It yields this value. What's happening here? The counter coroutine yields values. Where is the counter? Coroutines here. It's type generator. It's the type of this structure. So most probably what happens here? There are some built-in methods that need to be implemented in the structure in order for it to be coroutine, right? The counter coroutine yields values. The generator class represents a coroutine object and encapsulates a coroutine state. The next method, here's the next. The next method resumes the coroutine and allows it to produce the next value. When you call gen next, it's here. No, it's not here. It's here. The coroutine is resumed and produces the next value, which you can access with the gen value. So how does this work? This is a counter. We created a counter here. We created a generator here. Why is it called auto? Why is the type of this auto? No idea. So while there is a next in the generator, I'm printing this out and I'm ending the line, I assume. And here I'm yielding most probably every next is triggering a yield. Okay, C is not exactly my strong point. The coroutines allows you to write straight line code that can yield to the caller and resume at some later point. This can be used similarly to async await. Yeah, from languages like Rust, C#, JavaScript, Python, and Swift. Okay, nice. Introduce it in C20s is When was this? When was C++20 officially released? In 2020, right? February 2020. Okay, so C++ took 30 years to implement asynchronous code. This can be used similarly to async await from languages like Rust, C#, JavaScript, Python, and Swift. When a typical blocking function waits for a long-running operation to complete the whole thread and any resources become blocked until the operation is done. By contrast, the coroutines can yield to their caller and only resume once the asynchronous operation completes. Okay, and why do they require dynamic allocation? So the coroutines use heap allocation by default, but heap allocation isn't available on many embedded platforms. At an embedded platform, I assume, what is an... Shit. No. An EMPB short for Erstmusterprüfbericht. Erstmusterprüfbericht, or is a key document. No, this is not what I want. What is an embedded system? So, from my limited knowledge of low-level programming, I would assume that an embedded system is a closed circuit that has certain computational power on it. I don't know, stuff like the Game Boy, or even something simpler like a specialized computer system, like an, I don't know, electronic clock or something. MP3 players, thermostats. What's this? What? I have no idea what is being said here. This is a fairly long article, so I'm sorry. We're gonna need to skip this one. I'm really sorry. Also, it's just boring. How do I strike through? Is it like this? This? Is it only one? No, what is this character here that I use for lambda? It's a tilde, right? It's a tilde. Why can't I? Do I need to? Ah. No, I don't need to. It doesn't work. Why can't I strike through it? Heading, horizontal rule. Is this a bug in Joplin? Look at this. Why? Why is this not working? Because this is a fucking link. But still doesn't work. Now these are the things that are gonna make me insane. I won't be able to read the next articles until I fix this thing. Error. So what happens if I copy this? If I copy this here. Is it the link? I think it might be the link that's causing this. No, it's not the link. Ah, it was the link. It was the link the whole time. It was the link the whole time. How do I create the links here? Yeah, like this. Okay, let's find another article. Smolderingly fast bee trees. And this is a part of a series on the design of a language. See the list of posts here. I like these articles, and especially from geniuses that just go deep and break down the language for us lower intelligence humans. How safe is Zig? 3 months of Rust. So Jamie Scattered Thoughts, Jamie Brandon. Okay. This part is a series on the design of a language, but where is it? Fast. Ah, here it is. I also saw something nice here. A practical query compiler in 500 lines. No. Baby second WASM compiler, baby's first shape of data. What's this? No. Okay, I don't care about this. Let's. Let's read the Smolderingly fast bee trees. So, just a quick note. I closed one of the articles that I was reading. You know, sometimes it's about me learning stuff, and it's about me finding what suits me and reading about it. Maybe I'm just having a bad day and I'm not having energy, or my thoughts are scattered, like the name, like the name of this web page says here, and I can't make myself read something. You know, I can have bad days. In the end, I'm not a teacher, and I'm not teaching you anything. If I think you shouldn't be learning stuff from me, I'm learning it myself, and you are learning with me. So basically, I'm just streaming myself learning. So sometimes I might close something that you might like, or I might half-ass something else, or whatever. I'm not an academic. I would like to be, but I'm not. So, you know, don't take what I do, don't take it too serious or too close to heart. Let's continue. Smolderingly fast B trees. What's a B tree, first of all? Many scripting languages use a hash map for their default associative data structure. So first of all, a hash map. What is a hash map? I know the basics of a hash map. The hash map is a data structure that is created using the hash, meaning it stores key value. It stores key value pairs, and it has the yeah, I wanted to mention this, the hash function. Basically, based on the hash function, we associate keys to the values inside the hash map. And in C++ and Java, it's commonly used to map keys to values efficiently with the ability to perform insertions, deletions, and lookups in constant average times of 01. Okay, so we have key value pairs, we have hash function, we have ways to handle collisions when two keys produce the same hash value. Insertion, deletion, and lookup generally take 01 time on average. Why? Because based on the hash function, we can generate the index in 01 time, and we can insert it in 01 time. But in the worst case scenario, the performance can degrade to ON. Hash maps are often used for fast lookups like dictionaries or caches, where you need to quickly retrieve data based on a key. For example, mapping user IDs to user data or storing configurations by key. And we have hash map in different languages. So in Java, C++, in Java. Okay, simple, nice. So it says here, many scripting in quotes, use a hash map for the default associative data structure. Now, hash tables have a lot of annoying properties. Okay, I'm not looking at it. You can see me, but I'm not looking at it. So what are annoying properties of hash maps? Collisions. So it's a fast algorithm. I don't think the speed is problematic. So most probably collisions. Hash flooding, I never heard about hash flooding. If protected against hash flooding by random seeds, the iteration order becomes non-deterministic, which is annoying for snapshot testing. What is hash flooding? What is hash flooding? May have to rehash on insert, which produces terrible worst-case latencies for large hash maps. Repeatedly growing large allocations without fragmentation is difficult on custom targets. Like, oh, these are really complex points here. What is hash flooding? So hash flooding exploits hash collisions where multiple different inputs generate the same hash value, causing a degradation in performance. Interesting. Interesting. Hash tables are designed to distribute entries evenly across various buckets using a hash function. A hash collision occurs when two or more keys produce the same hash value, causing data to be placed in the same bucket. Okay. These are the basics of hashing. But what else? Okay, so basically the attacker, what is the attacker doing? He generates a large number hash loading attacker generates a large number of keys that produce the same value. I'm just writing this. Since these keys all map to the same bucket, the hash table degenerates into a linked list. Yeah. Interesting. Really interesting. So these are vulnerable to, just a second, let me move this instead of here. I'm gonna move it here. Nice. So the point here is that hash tables have some negative properties to them. So what is the alternative? The alternative is an ordered data structure like a B tree. Can you explain me what a B tree is, how it works, and give me some info on it? Ordered data structures like B trees don't have any of these disadvantages. They are typically slower than hash maps, but I was surprised to find fairly wide variations in people's expectations of how much slower. So let's compare. So what's this? Is this just a benchmark article? Micro benchmarks are hard. Let's start with the dumbest possible benchmark. Fill a map with uniformly distributed random integers. Measure how many cycles it takes to look up all these integers and take the mean over many iterations. Okay. So fill a map with uniformly distributed random integers. Measure how many cycles it takes to look up all these integers and take the mean over many iterations. For keys, key, this is, I don't know what languages this is, but I assume this is a collection. This is an individual key of this collection. I get a key, value found. If value found is equal null, panic. What? What kind of language? What language uses panic? It's an emo language, an edgy language. So this Rust. Zig. Yeah, element being iterated. Is it? The panic function is used in Zig to handle unrecoverable errors. Fuck me. So if value is null, error value not found, but what is this doing? What is RDT scope doing? RDT scope function is often used in low-level programming language as to access the CPU's timestamp counter. So what's this? This is like a this like a timer in JavaScript, right? So it tracks the time. So we have a record, map count, so this makes B trees look pretty bad. So there are other benchmarks in which similar sizes B trees are only 2x lower than hash maps. Where's this? So, okay. I'm not interested in this article either. I mean, these are specialized articles. I'm more interested in, for example, this talks about B trees. I'm more interested in what a B tree is. And here it says a B tree is a self-balancing tree data structure that maintains sorted data and allows for efficient insertion. Okay. So a B tree. A B tree is a self-balancing tree data structure that maintains sorted data and allows for efficient insertion, deletion, and search operations. It's used where? File system where a large amount of data needs to be stored and accessed efficiently. So B means balanced. Okay. So, what are some points of a B tree? It's a balanced tree, it's a multi-way tree. And each node can have multiple keys and multiple children, where each key separates a child subtree. It has efficient disk access, and they have some node properties. Each node contains a certain number of keys, typically defined by a parameter t. Let me think about it. So each node contains a different number of keys. Typically defined by a parameter t, called the minimum degree. Each node has at most 2t minus 1 keys. Each internal node has at least t children, except for the root, which can have fewer. Wait, so node contains keys, and the keys are defined by a parameter t. Each node has at most 2t minus 1 keys. Why? And each internal node has at least t children, and we have searching, we have insertion, we have deleted. Give me an example, man. Each example of a B tree of variation. Searching for a value in a B tree starts at the root, and at each node a binary search is performed. If the search key is not found, it proceeds to the appropriate child pointer. I have no idea how this works. Basically, it didn't explain how it implements it, and what the fuck. Why is it happening again? Okay. let's do another one. What is fuzzing 101? A step-by-step fuzzing tutorial. Do you want to learn how to fuzz? What's fuzz? What is fuzzing? Fuzzing or fuzz testing is a software testing technique used to find security vulnerabilities and bugs by preventing invalid, unexpected, or random data and inputs to program. The goal is to cause the program to behave unexpectedly, such as by crashing, throwing exceptions, or providing incorrect outputs, revealing potential weaknesses. Okay. Let's learn about fuzzing. Fuzzing seems interesting. Fuzzing seems fun. Since I'm 6 drinks in for 20 bucks, let me tell you all about the story of how the first Microsoft Office 2007 vulnerability was discovered, or how it wasn't. This is a story that I was gonna save for a book, but fuck it. I ain't gonna write it anyways. So thread reader. What? Ah, okay, so this is a thread. This is a Twitter thread. Interesting. Okay. I'm 6 drinks in for 20 bucks. Let me tell you all about the story of how the first Microsoft Office vulnerability was discovered, or how it wasn't. This was a story I was gonna say for a book, but fuck it, I ain't gonna write it anyway. So my first month at working at EI, Microsoft announced Office 2007. They added some security data, and I told my boss I was gonna break it. I'm the kind of sicko who can open a Microsoft Office document in a hex editor and start telling you what it is all about just by scrolling down. Wow. I have spent an embarrassing amount of time looking at BIF format in a hex editor, and trust me, it's nothing special. So I start manually fuzzing legacy Word documents. I literally bring up Office 6.0 documents and start manually fuzzing the legacy controls in them the day Office 2007 drops. After 36 hours, I get a promising hard crash in good old Word. I start digging, and it is from a legacy conversion function converting an ancient word art structure into a modern structure, and it correctly trusts a user calculation to control a pointer. Game over. Wow. Okay, so how this happens? It converts an ancient word art structure into a modern structure, and it incorrectly trusts a user calculation to control a pointer. Game over, or so I thought. So at EI, we have a senior review every bug we report, and my boss looks over the issue and gives it the green light. I take it to assume this is a supervisor of his, a superior of his, and he sends it right over to Microsoft and starts a press release, as one does. So Microsoft starts reviewing this clusterfuck, and as you can imagine, since it's a brand new product, they call in their A team to review it, including none other than David LeBlanc, the creator of SafeInt and a huge component of the safety of Office 2007. David looks over our crash. We are high-fiving each other in their office, literally strutting around like rock stars. Except LeBlanc comes back and says so about that crash. It's only exploitable when a debugger is attached. What? What? We look it over. There's a fucking 0xcc OP code that we blew past in our code path. We tested and replicated with a full exploit only with a debugger. Okay, so out of the narration, the tweet author, the tweeter, is switching to mojitos. Okay, so we reviewed the bug and he's right. We submitted an exploitable condition only under a debugged process and literally contacted every press release. Every single one. There's like 8 major news articles saying we have an exploit in Office 2007 in under 48 hours. So Mark calls us in the office and sits on us down and tells us the news. I have literally been on the team for less than 2 months. I feel fucking awful. I feel fucking dumb as fuck. I have let down this incredible team. And I'm utterly devastated. Mark says, well, I'm not retracting the press release, so you better give me an O-day. So what I assume an O-day is, in the context of fuzzing, what is an O-day? It's a 0-day exploit, right? It's a security vulnerability or software flaw that is unknown to the software vendor or the public. It means the vulnerability has been discovered, but no official fix or patch is available. Attackers can exploit this flaw before the vendor becomes aware of it or before a patch can be issued, hence the term 0-day. Okay. I feel awful, I feel dumb as fuck, I have led this incredible team. Okay, so you need to find a 0-day. Again, I start manually fuzzing again by myself, terrified for my life. I have to find a 0-day ASAP to save face, like yesterday. I'm over my head, but I go. And to my dismay, the entire research team comes over and says, we are in this together, let's do this. We are all in the office for days, 24 hours, ordering pizzas, ordering Mountain Dew, reversing, making fuzzers. We are all in this together. Every single researcher. We made 4 different fuzzers, an analysis toolkit, and a binary decompiler of the BIF format. Drew makes an HTML fuzzer for web objects. Yuki Ukai and Eric Soder start reversing every cache we come up with. Me and Andre are fuzzing like no one has ever fuzzed. 3 days go by and we all haven't left the office. Girlfriends and wives are calling and yelling, pleading and begging for each of us to come home, but everyone stays. They haven't yet found anything serious. And there was a fuzzer hit. The crash has a full EIP override. Okay. So they confirm it. They start reversing the crash. It's in the publisher. The website developing tool in Office that no one uses is the publisher in Office. Is this a bug in fucking ChatGPT? I'm getting these links which are from the first question that I asked, where I mistyped something. Microsoft publishes a desktop publishing application that focuses on layout and design rather than text-heavy document editing. Okay, so it's a web developing tool. Greg, this crash is good. It's a pointer override because of an integer overflow. We retest without a debugger. We retest on fresh OS install, it fucking crashes at the same spot. The entire research office explodes. We have found a alleged vulnerability and it bypasses SafeInt. I'm literally crying because it's my first professional job and I had fucked up so bad. But every single researcher they stayed. Guys, I love you so much. Why is Drew lowercase? Who writes like this? Is this a Greg Linares? Okay. So they wrap the bug. They say this looks like it might be something. David LeBlanc is on horseback 100 miles out of Seattle on vacation. So guess what? Fucking what? They recall his vacation. So we get a receipt from Microsoft. They call LeBlanc. Mark is tossing even more interviews. Derek Soder has writing a full sexy RCI with kernel privileges exploit. So they really found an exploit. So they have an explanation of the exploit. I would like to read this as well. Then some motivational messages. Okay. Interesting. Ooh, it's 1 hour. So I'm gonna stop here and we're gonna continue in the next episode. Thank you and bye bye.